Hello friends, I come with another video here that continued from Siemens S7 300 CPU and the IFM distributed I/O module data sharing. So on this part, I will focus on the Festo module. The Festo module. The module looks like this one as you see on my screen. So I will connect this module to the IFM module and it will get its data from the Siemens PLC. So the wiring, let's see the wiring first. The wiring looks like this one. Here is the distributor module. It's M12 connector. So as you see here, it's connected like this one. The plus is 1 and 2 and 4 are signal. 3 is for minus and 5 is the ground. So the wiring looks like this one. Also, I want to say it has 8 solenoids. 8 solenoids. 1, 2, 3, 4, 5, 6, 7, 8. So one solenoid has also two actuating inputs. So it's not self-returning or it's not spring actuated. It always need a signal to actuate. So as you see here, 12 and 40. Okay, that's it. So all 8 solenoids will get their data by those four cables. That's the main advantage. So let's start the Siemens program. First, let us do the hardware configuration. Okay, the hardware I have already done for the input and for digital input and the digital output. For this one, I will add for the solenoid. It's like input output. I will use this one. So add this here. So this is the Festo. Okay. Sorry, let's add the property now address. Let's say the address is 50. And so this one 50. Okay, here. That's good. Great. Okay. So on this part, we are connecting a solenoid module. So we have to read the status of that port. Also, we have to write some data on that port to actuate the solenoids. That's why it shows input side here, an address in the output address also here. Okay. So let's save in the compile the hardware. So okay, let's now insert one function. I am creating one function that controls the Festo module. If you have many, so you can use this function. So let's say function 30, and this is going to be the Festo control Festo module controller. So I will do one function for my all Festo modules. That's the advantage. So let me open and try to create the program. Okay, to save time, let me again write my program. It will take time to write. Okay, I'm done writing the program, so let me try to explain for each one. Let's focus on my local variables. Okay, here on the input I have to get the input address, the input starting address, and the output starting address also here. Also the signal for controlling valve 1, input 12, input 2 and 4. That make me this one 12 and 40. So to control this one, I have to get signal for this input, the actuating input 12 and the actuating input 40 for one bulb. That means bit 0 is for 4 and bit 1 is for 2. It shows here. Okay, great. So that's why I do here 2. For bulb 1, in actuating input 40 and actuating input 12. For also bulb 2 is the same here, 2 variables, and for bulb 3 like this. For all 8 solenoids, I have to put two variables. So I will try to use this letter. So let's go to the output. On my output side, I have to get the port status or 5. That means port is detected, port faulty, and port data valid. Also, reading of data block is okay. Reading of writing of block data is okay. So I have put those variables on the output. Let's go to on the temporary. On the temporary side, I have added those variables to struct variables, and also starting address here, the for input, starting address for the output, this one. So I have to move these two variables to my temporary, then I will use those things later. So on my inputs, when I have to put or write my reading data from the port will be stored on this one. It's like the sorry. As you see, the starting address is 50 and 4 bytes for the input, 4 bytes for output, and 1 IO link or PQI. That means for reading, I have to use 5 bytes. Here, as you see, this is double. I am not going to use for reading the 4 bytes. I only use the PQI value. The PQI value is this one. This 1 byte. That starts from 4 to 7. 4.0 to 4.7. Okay. This is the what I get from that port to know the status of that port. For the output, also I have to write for opening and closing one solenoid, and also for opening and closing solenoid 2, and likewise for 8 I have to use that one. Totally 16 bits, but my output is 4 bytes, so I use 2, so I only add one dummy that is not used. So to make it, I will put here, I will make 4 bytes now. It becomes 4 now. Okay, so these are the starting address and the starting address of the input and our starting address of the output. Here is this error code stored here, and this is a temporary value for inputting the this one, the port status. So I have already done for the variables, for the local variables. I try to explain. So let's do the programming now. The program is almost the same with my last video, so only differs a little bit. So let's see that one. Here I try to move my input address to the temporary variable. Here I moved this one to the temporary. Then I use this temporary address to read the port status. This one, system function 40, that is used to read DB slaves here. So I will record or store the data to local variable 00 for local data 00 starting 00 for 5 bytes. This one, this has 5 bytes. This is the DME has a double word, that means 4 bytes, and for the PQI 1 byte, so totally 5 bytes. So I will read this one here. Then after I read, I will, if reading is okay, if the binary result is 1, it will go next. If reading is not okay, it will put 0 to the fill byte, and it will fill the temporary data with 0. That means flashing the memory of the input at the temporary. If reading is okay, it will go next and do the status of the port. After we reading, we will know the status of the port faulty or port detected, port faulty, and port data valid. We will get the status after reading. Okay, so we done for the reading, so let's do for the writing. For writing, we have to parameterize or write the input datas, those datas, to move those input variables to the temporary here. So this one, sorry, right output here. We are moving the input to the temporary here to move to the to write to the port. So I write for all solenoids here, for solenoid 1, solenoid 2, solenoid 3, solenoid 4, and for all 8 ports I write for here. I write it in HTML to save time here, and for also for there is a dummy variable because I use 2 bytes, but the output is 4 bytes, so I will add one dummy variable here. So I move 0 to that also. Then after I parameterize the temporary output to, then I will move the starting address of the output. This one 50 move, then I will write to that port using system function 50. So the address is output starting address, then the record will be starting from 6.0 to 4 bytes. Let me show you this one. 6 is here, so starting from here 4 bytes means there are 4 bytes under it, that it includes 4 bytes. So I will send this or write these values to that port or to control the Festo module. Okay, I'm done. Then this is to Complim is the writing of the data okay or not. I will Complim by this variable. So I created one function that controls a Festo module connected to the IFM module, this one. So I have created one function, so let's use that function to create Okay, so let's use that one now. I have created for the digital input and the digital output. So let me add for the Festo module. Festo module. So the function is function 30. Okay, great. The input start address is 50. The output starting is also 50. As you see here, 50, 50 starting address. Okay, this one is memory, let's say 50.0, 1, 50, 2, 53, 4, okay, 50, memory 55, memory 56, memory 57, memory 51.0, memory 51.1, memory 51.2, sorry, memory 51.3, 51.4, memory 41.5, memory 51.6, memory 51.7. So these memory bits are controlled by another program to actuate that solenoid. For example, memory 50 dot memory 50.0 and the memory 50.1 are used to control solenoid 1 or valve 1. To open I use memory bit 50.0 and to close I use memory bit 50.1. So these two memory bits are used for controlling one solenoid or one valve. Okay, and here to get the status I use memory 52.0, memory 52.1, memory 52.2, memory 52.3, memory 52.4. So I'm done for one port. If you connect more Festo modules or use more ports, you can add another network and use this function. That's the main advantage. Okay, I'm done creating for the Festo module. That the Festo module, as you see here, is very interesting and it saves the cabling line and also easily troubleshooting or easy fault analysis. Thank you. Have a nice time. I will do for the digital. Sorry, I will do next my video on analog input module input. Or till then, have a nice time.